friends, today we are going to start our discussion about the electronics, that means the semiconductor electronics, materials, devices and simple circuits. Right? This chapter, the weightage of this chapter in board exam is 7 marks. Right? Okay. So here the some portion are cancelled by the board, but here the classification of material, that means the solid, into conductors, insulator and semiconductor is important to understand or to discuss about the semiconductor. So what is the basic difference between conductor, insulator and semiconductor? For that purpose, it is necessary to get the information about classification of solid into conductors, insulator and semiconductor. Okay. Already in chapter 3, current electricity, we discussed about the electric current. Electric current is formed due to the motion of electron in solid or the metal. Metal is formed by the two types of the ion, negative and positive ions. Negative ions are the electron, while the positive ions are fixed at their lattice point. Due to the potential difference applied across the metal, positive ions does not move. Only the electrons are moving and forms the electric current. Already this point we discussed in chapter 3, current electricity. Okay. Now, electrons are moving. So the question arises in our mind that for all the metal, as we apply the potential difference or as we change the temperature, all the electrons are start to move? No. That is depends on the type of metal. That is depends on the type of metal. Some metal has the more number of the free electrons, while the some metal or the some material has the less number of the free electrons. The conductivity of a material is depends on the number of free electrons in it. Some metals are not the good conductor of the heat or the electricity due to the absence of free electron. While the some metal like as the copper, aluminum are the good conductor of heat and also the electric current. Because in aluminum and copper has the more free electrons. Therefore, the aluminum and copper are the good conductor. So in short, conductivity of a material or the metal is depends only the number of the free electron. Number of the free electron. Already in chemistry and physics we discussed about that. In the formation of any metal, the positive ions and electron are bound with each other. While in some metal, the some free electrons are already present in particular metal. Right? Okay. At STP or the normal temperature and pressure, if the free electrons are absent in material or the metal, so this material or the metal is act as an insulator. And the metal those have the some free electron at STP. So this material or metal act as the conductor. Now what about the semiconductor? Semiconductor, that means at 0 Kelvin temperature, it behaves as a perfect insulator. As the temperature increases, so the free electron arises. How the free electron arises? Because at 0 Kelvin temperature, all the electrons are bound with positive ions and forms the covalent bond. That means all the electrons are formed or used to form the covalent bond. No any free electron at 0 Kelvin temperature in semiconductor. Therefore, absence of the free electron, semiconductor act as a perfect insulator at 0 Kelvin temperature. Right? Okay. As the temperature increases from the 0 Kelvin temperature, so what's happened? due to the thermal oscillation of positive ions. So some covalent bonds are broken. As a result, the electron becomes the prey and positive ions also becomes the prey due to the broken of the covalent bond. So as a result, the semiconductor at 0 Kelvin temperature already act as a pure insulator. Now, the conductivity in this material start to increase due to the electron becomes the prey from the covalent bond. So in short, as the temperature increases, so the conductivity of the semiconductor increases. Clear this thing? While for the metal, as the temperature increases, so the conductivity of the conductor is decreases. Conductivity of the conductor is decreases. Clear this thing? So that is the main difference between the conductor and semiconductor. For the conductor, the graph of the resistivity versus temperature is like this. As the temperature increases, so the resistivity increases for the conductor. And while for the semiconductor, the graph is opposite to that. That is the resistivity of temperature T here. At 0 Kelvin temperature, the resistivity is maximum. That means the conductivity is less. As the temperature increases, so the conductivity is increases, resistivity decreases. That is for semiconductor. So that is the main difference between the conductor and semiconductor. In this chapter, first we have to discuss about what is the semiconductor, what is the characteristic of semiconductor, intrinsic semiconductor, that means the pure semiconductor, and then the extrinsic semiconductor. That means as we add the impurity atoms in pure semiconductor, so drastic change take place in the conductivity of a semiconductor. After that, these two types of the pure semiconductor are combined to form the junction. So that is known as the PN junction or PN junction diode. Clear this thing? So for that purpose, first we start our discussion about what is the classification of the conductor, insulator and semiconductor on the basis of the value of conductivity and resistivity. Right? There is only for our base for the understanding. That this question, this information is not asked in exam, but to start our learning about the electronics, it is necessary to know that what is the difference between the conductor, semiconductor and insulator. Just here we discuss about the conductor and semiconductor, the relation between the resistivity and temperature. Already in chapter 3 we also discussed the relation between the resistivity and temperature, or resistance and temperature. RT is equal to R0 into bracket 1 plus alpha T minus T0. That is the relation of resistance and temperature for the metal. Okay. Now for the alloy, that means the insulator. So the resistivity does not change with change in temperature. That means the very small change takes place in resistivity of an insulator, almost constant. Okay. Now the classification of the conductors, insulator and semiconductor. The question is that classify a solid substance based on electrical conductivity and resistivity. On the basis of conductivity and resistivity, how we classify the solid. For that purpose, on the basis of relative conductivity, rho sigma, and resistivity, rho is equal to 1 upon sigma, the solid are classified by 3 ways. That means the solid can be classified in 3 ways. First is the conductor. First is the conductor. Conductor possesses the high conductivity and less resistivity. Conductor has the high conductivity and low resistivity. The value of conductivity for the conductor is 10⁻² Simon into meter inverse to 10⁸ Simon into meter inverse. What is the Simon? Simon is equal to mho or reciprocal of ohm. Reciprocal of ohm. What is the Simon? S is mho or 1 upon ohm. Okay. That is for understanding. And for the conductor, the value of conductivity 10⁻² Simon into meter inverse to 10⁸ Simon into meter inverse. While the value of resistivity is 10⁻² ohm into meter to 10⁻⁻8 ohm into meter. That means for the conductor, resistivity is less, conductivity is much more. So easily the conduction of electricity and heat take place in this type of the solid known as the conductor. Now next, there is the semiconductor. Semiconductor is the material or the solid. They have the conductivity or the resistivity intermediate of conductors and insulator. That means the metals and insulator. Most of the metals are good conductor of the heat and electricity, and due to that reason, generally instead of the conductor we can also add the metal. Metal are the good conductor of the heat and electricity. Again, the semiconductor have the conductivity or the resistivity intermediate of metals or the conductors and insulator. The value of the conductivity for the semiconductor 10⁵ Simon into meter inverse to 10⁻⁻6 Simon into meter inverse. While the resistivity is 10⁻⁵ ohm into meter to 10⁻⁶ ohm into meter. These are the value of conductivity and resistivity for the semiconductor. Now what about the insulator? Insulator have low conductivity. That means the less value of the conductivity or high resistivity. Resistivity for the insulator is much more. Therefore, the value of conductivity is for the insulator is 10⁻⁻11 Simon into meter inverse to 10⁻⁻19 Simon into meter inverse. While the value of resistivity is 10⁻11 ohm into meter to 10⁻19 ohm into meter. So there is the classification of solid into conductor, semiconductor and insulator on the basis of conductivity and resistivity. Clear this? Okay. After that, explain the classification of semiconductor with example. So how many types of the semiconductors are available in the market, or at present we are using the semiconductor in most of all electronic devices, like as the oven, fridge, also washing machine, TV, like as the LCD, LED, also in our computer, mobile. This type of the electronic gadgets or the devices, we are using the semiconductor. Due to the invention in semiconductor branch, right? So day by day, the size of the electronic component is reduces, and due to that reason, we know that at present the mobile available in the market is lightweight and also very small in size. Okay. Now explain the classification of the semiconductor with example. The semiconductors are in the original element and compound element. So these semiconductors are also classified in three different ways. One is the elemental semiconductor. Elemental semiconductor. So in this type of the semiconductor are prepared from the pure silicon or the pure germanium. Again, the semiconductor are classified in three way. First is the elemental semiconductor. This type of the semiconductor are prepared from the silicon or pure germanium. Okay. Now, next is the compound semiconductor. Compound semiconductor are two kinds. First is the inorganic compound semiconductor. Okay. These are the inorganic semiconductors are cadmium selenide, the cadmium sulfide, CDS, GAS, gallium arsenide, CDSE, cadmium selenide, INP. That means the indium phosphorus, etc. are the inorganic semiconductor. Keep in mind the value of inorganic semiconductor. Cadmium sulfide, gallium arsenide, cadmium selenide, indium phosphorus are the inorganic semiconductors. Generally, the 1 marks question are asked. Which of the following are organic semiconductors? Cadmium sulfide, gallium arsenide, cadmium selenide, indium phosphorus. Now, organic semiconductors are anthracene, doped, phthalokenins, etc. are the organic semiconductors. Anthracene, doped, phthalokenins, etc. are organic semiconductors. And now next is organic polymer. Polypyrrole, polynylene, polythiophene, etc. are the organic polymers. Again, the organic polymers semiconductor devices are polypyrrole, polynylene, and polythiophene, etc. are organic polymers. Right? Okay. Most of the currently available semiconductors devices are based on elemental semiconductor. What are the semiconductors used at present? Are made from the elemental semiconductor, that means pure silicon and germanium, and also the compound inorganic semiconductor. That means the cadmium sulfide, gallium arsenide, cadmium selenide, and indium phosphorus. After 1990, a few semiconductor devices using the organic semiconductors and semiconducting polymers. After the 1990, a few semiconductor devices using the organic semiconductor and semiconducting polymers have been developed, signaling the birth of futuristic technology of polymer electronics and molecular electronics. Electronics is not a single branch. At present, the wide invention take place in the electronic branch due to this type of the polymer electronics and molecular electronics. The technology becomes the very fast at present. Right? Okay. Now, after the 1990, a few semiconducting devices using the organic semiconductors and semiconducting polymers have been developed, signaling the birth of futuristic the technology of the polymer electronics and the molecular electronics. So that is the basic introduction information about the semiconductor and also the classification of solid into conductor, insulator and semiconductor. After that, we start our discussion about the energy level. Right? the next question is about the energy diagram or the energy band structure. Right? They explain the energy band, valence band, and conduction band in crystal. What is the necessity for the learning about the energy band? Already we classified the metal into the conductors, insulator, and semiconductor on the base of the conductivity and resistivity. The relative value of the resistivity and conductivity are not only the measure to classify the solid into the insulator, conductor, and semiconductor. Right? The Venn diagram is also the important tools to classify the solid into the conductor, insulator, and also the semiconductor. For that purpose, we are also going to learn about the energy band or the energy band diagram. Clear it? Okay. That is also only for our understanding and knowledge why the N-type semiconductor and P-type semiconductor, what is the difference between them? And what is the difference between the conductor, insulator, and also the semiconductor on the basis of energy band diagram? Right? For that purpose, the question is that explain the energy band, valence band, and conduction band in crystal. Okay. Now, in some solid have the crystalline structure, that means the systematic arrangement of atoms and molecules in it. Now, generally we know that in metals or the solid have the crystalline structure. That means the systematic arrangement of molecules and or atoms in it. Now, what's happened? When the atoms are close to other atoms, get intact with the neighboring atoms and also the atoms. When the one atom in crystal is very close to the other atom, that is the crystalline structure. At that time, what's happened? The interaction between the neighboring atom and other atoms, as a result, the energy of the electrons of the atom are changed. Each and every atom has the, like this way, according to the chapter of nucleus, the small central region, here the positively proton and chargeless neutron are present, while in outer shell, the electrons are evolved out the nucleus in a circular orbit. So these orbits are known as the shells. Right? Okay. So when the atoms are close to other many atoms, get intact with the neighboring atoms and other atoms. As a result, the energy of the electrons of atoms are changed. The energy level of inner shell electrons are not affected, but the energy level of outer shell electrons are changed. Okay. Here the electrons are evolved out the nucleus in inner shell orbit and also the outer shell orbit. When the one atom is close to the another atom, at the time due to the interaction between the atoms, the energy level of these electrons, outer shell electrons, are affected, while the inner shell electrons are not affected. The energy level of inner shell electrons are not affected, but the energy level of outer shells electrons are changed, since the electrons are shared by more than one atom in crystal. So what are the electrons in outer shell of one atom are shared or going transferred to the other atom in the outer shell. Therefore, the energy level of atom is going to change. Right? The electrons of the atom in the crystal has closely spaced different energy levels. The electrons of atoms in the crystal has closely spaced different energy levels. Instead of the widely separated energy levels of electrons of insulator. Right? In crystal or the metals or the conductor, the electrons of the atoms in the conductor or the metals has closely spaced different energy levels. Instead of widely separated energy levels of electrons of insulated atoms. Such bands of closed energy levels are known as the energy band. What are the energy levels of the electrons which are closely spaced? Right? These energy levels are known as the energy band. These are known as energy band. Clear this thing? Okay. So what is the energy band? The electrons of the atom in the crystal has closely spaced different energy levels. And these energy levels are known as the energy band. The valence electron, that means in last outer orbit, are known as the valence electrons. What are the electrons in last orbit of the atoms are known as the valence electrons. The energy band, which includes the energy levels of valence electron, is known as the valence band. Now, the energy band in which contain the energy levels of the valence electron. What is the valence electron? The electron in outer orbit of an atom are known as the valence electron. Because this electron easily transfer or moving from one atom to the another atom due to the interaction between the atoms. Now, this electron has the also different spaced energy levels. Now, the energy level which contains the energy levels of valence electron is known as the valence band. That is known as valence band. And the energy band above the valence band, that is known as the conduction band. That is known as the conduction band as shown in the figure. Okay. So there is the energy level of valence band. Just above of this valence band, the energy level of the conduction band. There is some gap between these two bands, valence and conduction band, that is known as the forbidden gap. That shows the difference between the energy level of the valence band and conduction band. Again, the valence electron in last outer orbit of atom are known as the valence electron. The energy band, which includes the energy level of valence electron, that is known as the valence band. So that is the valence band. The energy band above the valence band is known as the conduction band. That is known as the conduction band. Right? There is some gap between these two bands, that is known as the forbidden gap. This forbidden gap shows the difference of energy between the upper level of energy level of valence band and lower energy level of conduction band. Okay. Generally or usually, a valence band has a valence electron while the conduction band is empty. In normal state, the valence band contains the valence electron while the conduction band are almost empty. Okay. Now, there is some gap between the conduction band and valence band. The energy difference of this empty space is known as the band gap energy. That is denoted by Eg. On the base of the value of band gap energy, we can classify the metal into the conductor, insulator, and also the semiconductor. We discuss this point later when we discuss about the N-type semiconductor, P-type semiconductor. Okay. Again, there is some gap between the conduction band and valence band. The energy difference of this empty space, that is known as the band gap energy, that is denoted by Eg. It is denoted by Eg. Okay. How we classify the solid into the conductors, insulator, and semiconductor? Again, when the atoms comes very close to the other atom, at that time the interaction between the electrons of the atoms take place, or the one atoms interact the other, or the neighboring or the other atoms. So as a result, what's happened? Energy of the electrons of atoms are changed. Right? The energy level of the inner cell are not affected, but the energy level of outer cell electrons get affected or the change, since the electrons are shared by more than one atom in crystal. The electrons of the atom in the crystal has the closely spaced different energy level, and this energy level are known as the energy band. Now, the valence electron, that means in last orbit, outer orbit, or the electron in last outer orbit are known as the valence electron. The energy band which contain the energy level of valence electron, that is known as the valence band. The energy band above the valence band is known as the conduction band, as shown in the figure. Generally, the valence band has a valence electron, while the conduction band is empty. Okay. There is some gap between the conduction band and valence band. The energy difference of this empty space is known as band gap energy Okay. Now, on the base of this energy band diagram, what is the conductor, what is the insulator, and what is the semiconductor? When the minimum energy level of conduction band, that is the minimum energy level of conduction band, is lower than the higher energy level of valence band, that is the higher energy level of valence band. That means the both bands are overlap each other. The electrons in the valence band can easily move to the conduction band, and this happens in metals or the conductors. That means when the difference or the gap between the conduction and valence band is almost zero, or in other words, the valence band and conduction band are overlap each other. We discuss also in later. Right? So at that time, the electrons in the valence band easily going to the conduction band, and this happens only in metal or the conductors. Again, when the minimum energy level of conduction band is lower, then the higher energy level of valence band. So the electron or the valence electron of the valence band easily move to the conduction band, and this happens in metal or the conductor only. Now, what about the insulator? If there is some gap between the valence band and conduction band, the electron in the valence band are bound and no free electron in the conduction band. That means if the gap between the conduction and valence band is much more, no any electron can move from valence band to the conduction band. That means all the electrons in the valence band are bound, and conduction band is completely empty. This makes material and insulator. So this material is act as an insulator. And if the gap between the valence and conduction band is relatively small, and when the electron of the valence band get the external energy, crosses the band gap energy and goes into the conduction band. Again, but if the gap between the valence and conduction band is relatively small, and the electron of the valence band get the energy, external energy, and crosses this energy band the band gap energy and reaches to the conduction band. So in this situation, this metal is known as semiconductor. Hear this? Okay. So there is the energy band diagram, and on the base of the energy band diagram, what is the metal, or what is the energy band diagram for the metal, insulator, and also the semiconductor.